For our last example in the 1.3 notes, we will need our graphing calculator. It says let f of x equal 3 plus pi times 2 minus x. Use your graphing calculator to help you answer the following questions if needed. Always round decimal answers to 3 decimal places. So I'm going to take out my graphing calculator, and again, if I haven't used my calculator in a while, or if I want to make sure that nothing is running in the background from our previous day's notes, I'm going to go ahead and reset my calculator by hitting second plus 7, 1, 2. You get a message that says RAM cleared, so I'm good to go. So now I'm going to graph this function by going to y equals, and I'll type it in exactly as I see it. I'll type in 3 plus. The pi button is this blue button right here above this little caret symbol. To get anything that's in blue, we hit our second option and then the button that it's above. So now I see pi. And then parentheses, 2 minus x, close my parentheses. I'll graph it and see if I have a good window. I can see my y-intercept, I can see my x-intercept, and I can see the basic shape of this line, so I would say I have a pretty good window. Part A asks me to find the x and y-intercept of f and to give my answers as ordered pairs. Starting with the x-intercept, this should be a review from last time. We always hit second and then trace. Another word for x-intercept is 0, so we select option 2 that says 0. And then we have our questions, left bound, right bound, and guess. So right now I'm going to move my left and right arrows to the x-intercept, pretty close to the x-intercept here. And now I'm going to move it off the x-intercept just a little to the left, hit enter. I'll go back to my x-intercept, and now I'll move my cursor just a little to the right, hit enter. When I see this question guess, I just trace in between my 2 arrows to make sure that the x-intercept does fall in there. It does, so I'm going to hit enter one more time. And my 0 or x-intercept is 2.95. We're going to round this number 4 up to a 5, 0. So 2.955, 0. When I find my y-intercept, I know that the x value is 0, which is going to help me on my calculator. I can hit second trace, number 1 for value, and since I know the x value has to be 0, I just type in 0, and I get my y-intercept is 9.283. Okay. Part B is asking me to determine the end behavior, so I'm going to use my good limit notation. I'll talk about the limit as x approaches negative infinity of f of x, and I'll also look at the limit as x approaches positive infinity of f of x. So for my first limit, as the x values get infinitely small, as our eyes move to the left here, we can imagine our graph continuing to go up, which means that that limit approaches positive infinity. For my next limit, as the x values get infinitely big, so as my eyes now move to the right, they also travel down towards negative infinity. I now want to evaluate f of 4. As another reminder, whenever it's inside the parentheses like this, it is an x value. So this is asking, when x is 4, what's y? If we wanted to, we could hit second trace and number 1 for value again and type in the number 4. Or another helpful tool is to use our table, which we get when we go to second graph. And if we go down to when x is 4, we can scroll over and see that the y value is negative 3.283. So f of 4 equals 3.283. And lastly, when does f of x equal 10? We're looking for the x value when y equals 10. So we go back, when we go back to our y equals, we leave our function in there, and in y2, we type in the number 10. I hit graph, and I see this line going straight across up at the top. It's kind of hard to see the point of intersection though, so I am going to fix my window. Since I need to see further up on my graph, I'll change the y max to maybe 15, something a little bigger than what it is now. And it'll graph again, this time so that I can clearly see that point of intersection. To find that point of intersection, I hit second trace. Option 5 says intersect. And I move my cursor as close as I can get to that point of intersection and hit enter 3 times. The point of intersection when y equals 10 gives me the x value of negative 0.228. So x equals negative 0.228.